My great pleasure now to welcome our next speaker, Malcolm McCulloch, Associate Professor at the University of Oxford. He's Associate Professor in Engineering Science and a tutor at Christ College. In 1993, he moved to the University of Oxford to start up the Electrical Power Group. Now the Energy and Power Group in the Department of Engineering and Science at the University of Oxford undertakes computational and experimental sustainable energy research. The group's focus has now changed to developing and commercialising sustainable energy technologies. Malcolm's list of accomplishments is too long to read here. From personal experience, I find him one of the most lucid explainers of the situation we're in on the big picture and on how systems may work together to either bring forward quicker or to get in the way of the introduction of these new technologies. A fantastic speaker. Malcolm, please.
Thank you. When systems have been around for a long time, you need ever-increasing investment in order to eke out that little bit more value. However, when systems undergo rapid changes, the underlying ground rules and assumptions that have been made are no longer valid. And all that investment that you put into trying to understand the system suddenly has no value to you. How do you cope? Some do, some don't. And the trick is to go back to fundamentals again. And once you do that, you can start to ride this wave of change. I have as you might notice, I've got a really mixed accent. Some of it's from South Africa, but I'm now based myself in the UK. So I talk about change. I left the UK on Thursday night, a European citizen. I arrived here on Saturday morning to find that may no longer be the case. There's a system that's been around for a while having to deal with change. Let's make it a little bit more local. We've already just found out one of them. So what are the New Zealand's top 5 imports? You've got 20 seconds to talk to the person next to you and try and work out if you can work out what are the New Zealand's top 5 imports. Go. Right, your 20 seconds is up. And the answer is, you're going to have to wait. Let's go back to some fundamentals. So one of the things we did in our group is we said that because we believe the whole system is changing, what are some of the fundamentals that we need to hold on to? And one of the core things you'll find that I'll do in any presentation is I'll talk about sustainability, because that's kind of like the underlying ethos that we need to keep in mind when we look at changing systems. Sustainability is such a lovely, cuddly word that nobody knows what it means. So one of the things that we're trying to look at is to say it's maintenance of capitals. And there are 3 particular capitals that we want to work with. And by means of capital, I mean that which we have, which we can use to exercise, to do stuff with. The 3 capitals that I like to talk about are people. So what do people have? What do people do? What is their quality of life? What is their quality of the time that they have? What is the planet resources that we have to draw on, and how we can actually use those planetary resources? And prosperity, sometimes called profit, and depending on which type of audience you're talking to. So those are the 3 that we're looking at. And actually, this time last year, I was talking to Skip Leitner here in Wellington, and actually we recognized something, that actually there are only 2 capitals. That's people and planet. What the money does is enables and arbitrages between those 2 capitals. They're kind of useful because accountants can't track people or planet easily, so they can track the money. There's been a slight game change. We noticed that sometime last year we had Paris. And we noticed and recognized for the first time overtly that actually our draw on the planet has been a little bit too much, and we need to start to rethink things. So that's been a kind of a major game changer in the geopolitical world. Kind of interesting is that actually behind the scenes, both the 2 antagonists, that's both China and the US, both knew that this was the case 5-6 years ago, And all they were doing is playing delaying tactics in order to be able to get their own economies in the renewable space up and running, so that they, by the time they say, yeah, let's do it, they're ahead of the game. But anyway, be that as it may, things are changing. I want to talk, before we get into energy, into transport systems, I just want to talk a little bit about energy. And the energy system that we're looking at is changing rather rapidly. Now, if you go and look at a good piece of data which is given to us by BP, one of the only good things that they do in this world, but anyway, they collect all the traded energy data from around the world. And this is what's happened in the last 25 years. And a couple of interesting game changes that are happening there. So what you can see is that the top one's coal, then we got renewables, that little slither of orange there, then blue's hydro, then nuclear, natural gas, and oil. A couple of interesting things to happen. You can see 2008-9, that's when we had the little economics dip, and we can see that actually economics and energy are tightly coupled. So that's interesting. The second interesting thing is last year was the first of a whole number of different things. It was the first time that there's more oil consumed for energy than there was for coal. But what I'm interested in is more that little orange slither. Now, when you look at a graph like that, that kind of looks insignificant. When you kind of rebase this and you look at something where you can look at rates of growth, this starts to become a bit more interesting. So that's the same graph, except what we've done is we've plotted it on what we call as a log scale. So we can see how rapidly things are changing. And what we've noticed is that both wind in the blue and in the green, we've got solar, are rapidly changing. Now, what's interesting, again, I said 2015 was an interesting year. That was also the first year when more capital was deployed in renewable energy than in the whole of the coal sector and the whole of the oil sector combined. Okay, so things are really changing. Okay. What's also interesting is that things are becoming more electric. And we can see that about 20% of our energy goes into electricity, and we can see that something around about 2027, if you extrapolate that. By the way, it's always dangerous to extrapolate graphs, especially on the log graph, because a small change can swing things by 5 years. So this is just indicative. Don't quote me, say this is reality. But so something in the order of 2027, all electricity in the world will be able to be generated by solar alone. That excludes the role of wind. In my whole other life, I look at the role of energy, and the problem with solar, of course, during the nighttime it don't happen, so there are challenges there as well. But anyway, it just shows you how much the things are changing. And why have things changed? Well, remember I said that value propositions change when systems change. The value proposition of renewables is changing dramatically. This is the cost of solar panels. From in 1976, when they started getting going, looking about $100 per watt. And look what happened in 2008. We suddenly had a rapidly decreasing cost. It now takes 13 months for the price of a module to halve in price. That's a real game changer. So, you know how sunny the UK is. Over the last 3 years, we've installed 10 gigawatts, that's 10,000 megawatts, that's 10 nuclear power stations of solar in the UK. In March this year, the European Union has just crossed 100 gigawatts of solar installed. Okay? And the European Union is number 3 behind US and China. Okay? So things are changing. So what are the implications we have on today's talk? Well, here we come back to what are New Zealand's top 5 imports. And they are crude petroleum, cars, refined petroleum, computers and delivery trucks. And so a few others. So 4 out of the 5 are transport related. Okay? It's about 26% of the New Zealand imports are transport related. So that kind of says, actually, this is kind of important to you guys. So what is the impact of this energy transition going to be on transport? Well, we said that the new normal is going to be electricity, so obviously that's going to be the way that vehicles are going to have to travel. So we're going to see the rise of the electric car again. Just have a look at that advert. It's kind of stark. It's an electric vehicle that can do a 100-mile range. Date, 1908. Nothing new under the sun. What's the range of relief? About 100 miles. On a good day, exactly. Okay, so we can see that actually electric vehicles are something that have been around for a while, but you have to go back a hell of a long while. And in fact, in 1910, up to 1910, the major number of most vehicles were electric. It was only the advent of the starter motor in 1910 which actually transformed and allowed us to move into the internal combustion engine market. Remember what I said about systems being in stasis in the same era. That means from about 1910 up to 2010-ish, over 100 years now, we've had a transport system which has been geared around the internal combustion engine. Okay? That's going to take a little while to change. Also, a lot of our thoughts about what an electric vehicle looks like is stuck in the 1910s. So let's have a look at some of the myths that we have at the moment. A typical car for an electric vehicle in most people's mind is probably one of those, if you're lucky. For me, it's a milk float, but I think people moved on and it's a golf cart. So what's wrong with electric vehicles? Well, they're far too slow, aren't they? Who agrees that they're too slow? Yeah. Well, that vehicle there is fully electric, top speed of 205 miles an hour, 333 kilometers per hour. And it does that in just over 60 seconds. Okay. I'm kind of proud of this because the motors that we developed in our research group are in that vehicle. So we know how to do that. We also know that electric vehicles have no range. Okay, so we know that that doesn't happen. And we know that actually the world record for doing in 24 hours on an electric vehicle is 2,000 kilometers. Okay, so things can change. What's interesting with this is they're using a technique that was developed in Israel where they were actually doing battery swaps along the way. But they only had 3 battery swaps in that amount there. So what we can see is actually electric vehicles are developing, they are changing. The myths that we have are no longer necessarily valid. The last one, which is still some reality, is that they're too expensive. But if you go and look at a Twizy, okay, it looks a bit more like my golf cart again. But we can get it at something like 24,000 24,000 New Zealand dollars. And I've just noticed, read yesterday, that these should be arriving in New Zealand later on this year. Okay, and that's for a new vehicle. All right, so why are they so expensive? And the issue comes around battery costs. Okay, and one of the challenges around batteries is that they have taken quite a while to develop. This graph is kind of interesting because when I started working in sustainable transport about 5 to 10 years ago, a typical cost that was bandied around was about $1,000 for every kilowatt hour. So this is US dollars, apologies, so $1,400 New Zealand per kilowatt hour. Now, given that a Tesla comes in with something like 80 kilowatt hours, that's $80,000 just for the battery pack, and you go, oh crap, or words to that effect. Okay. Now, what's interesting is that if you have a look at those green dots, those are derived from looking at both the Tesla and the Nissan Leaf and looking at different models and looking what the marginal cost increase is from moving from different sizes of battery packs and trying to reverse engineer what the underlying true price to the manufacturers are. And you can see they're substantially lower. Now, what I've done is I've just taken those green dots out and re-put them in a graph that's a bit more easier to see. And that's what's happening. Okay, and we can see there's a trend coming down. Okay, so in the space of 4 or 5 years, we've gone from something like $550 down to about $300. Now, what's interesting is that when you hit about $150, you get to the point where for a mid-sized car, it's cheaper to make it, for the manufacturer, to make it an electric than it does for internal combustion engine. And that's kind of like the holy grail. Looking at that extrapolation from data up to 2014, it looks like we're going to get there in 2018. Okay, which is pretty soon. So some of the data that I've been gathering from my colleagues, which is not published, but it is still real information, is to show what's happened in the last few years and also what the firm orders they've got for next year. And those are the red dots. So we can see, actually, we're on track to do that. So we can see that by 2018, we're at a point where batteries are going to become the new normal for vehicles. And that's going to make a substantial change. Yes, there are other barriers. There's the whole perception of what does a vehicle do and all the rest of it. But one of the key barriers, I think, is going to be changing. So why is this happening? Well, remember I showed you in solar that in 2008, there's this dramatic change in the pricing. And what caused that? It wasn't the financial crisis. It was that in China, huge fabs came up where they were producing shed loads of solar panels. And now what's America has learnt, and a particular guy called Elon has learnt, that maybe we need to do the same for batteries. So to give you an idea, that's the size of a factory that has started being built last year. And this is where they've got to about a couple of weeks ago. And to give you an idea, if you get a feel for the size of that factory there so far, that's in the bit in the black square is how much they've actually built, and you can see what the total size of that's going to be. It's going to be the largest building on the planet. And they're going to be looking to produce up to 32 gigawatt hours of battery a year out of that building. That's going to be a real game changer. One of the things that a lot of people don't realize or don't know is there are 5 more of those going up in China. Okay, so this is going to be a huge difference. So here's another interesting question. What's the fastest grossing product of all time over a 2-day period? And the answer is the iPhone. No, it's not. It's the
Model 3.
Yay. Yes. So that's the Tesla Model 3 that's coming in. So a couple of interesting facts about it. It's now hitting $35,000 US for that vehicle, which is equivalent to like a medium to top end Toyota event that's coming through. But what's really interesting is that it's starting to address a question that somebody asked me about 5 years ago, and she said, why should I buy an electric vehicle? What does it give me that a conventional vehicle doesn't give me? And the answer is not that it's electric or green or anything else like that, but it actually gives me the chance to have more time. Why is that? Because these comes in with a built-in autopilot. And that's starting to give you times that when you're doing motorway traffic or things like that, it can take over and you can start to relax and start to do other things. Remember I said it's about a balance between the planet and people? Well, one of the most important resources for people is high quality time. So I believe this vehicle is doing both, trying to meet the planetary resources and trying to meet the people's timing system in that. The whole autonomous vehicles thing is something that we work within our group, and I'm going to not spend too much time with it today, other than to say it's coming, it's going to be dramatic, it's going to change what mobility looks like in the next 10 years or so. Okay, so but let's move on. Electric vehicles is not just about cars, although a lot of work has gone in cars to start off with because they're by far the largest segment in the road transport sector. But the other sectors are starting to catch up. Let's just have a look to see, before I go on to the other vehicles, to see, okay, things are coming through. That's the total annual sales of plug-in vehicles globally. So we're getting up to about 600,000 vehicles. Just to give you a rough idea, there are about 800 million vehicles on the road at the moment, and with a turnover rate of about one in 10 years or so, that shows that we're just touching 1%. Okay, it's small, but the growth rate is phenomenal, and it's going to go even faster. So I think we're in the point where we're going to be changing. I happen to know that after the Model 3 success rate, speaking to a number of the manufacturers in Europe, they have completely changed their strategy in the last 2 months. And a lot of them are starting to ditch internal combustion engine research, which is kind of interesting because 6 months ago, they were saying, oh, well, we'll do hybrids. There's no role for pure electrics. Remember what I said about a system that's inbred? There's a lot of resource gone into managing the existing system. They're going to have to lose that. Talk about a stranded asset. But it's not just about cars. Buses, quite interesting. So I'm not going to talk about China. I think Siegfried later on is going to talk about China, which is the largest bus fleet in the world, bar none. But there's some interesting things coming through where the Mercedes in Aachen are now doing articulated buses. So this is one of the largest buses and now pure electric. We in Oxford are getting double-decker buses, which is going to be the first double-decker electric bus in the world. It's going to come to us. But the challenge with buses is how the heck do you actually get the charge in while still maintaining schedules? Okay, because maintaining schedules is kind of the bedrock of any bus operator. Some interesting alternatives that are coming through is the Tosser, which is actually explicitly the trolley bus alternative. And I knew in Wellington how sensitive we were about trolley buses, so I thought just so that might be what your trolley line looks like. So just to give you, for the eggheads around you, to give you a bit of an idea, that's going to charge at 400 kilowatts. Okay, that's equivalent to about 400 homes, average power. Okay, that's going to charge for that for about 15-20 seconds at every bus stop. So while you're stopping, you do what they're calling a flash charge. They're using an exotic battery to be able to do it, but actually it's in volume, it could actually be quite cheap. So that allows you to now run a bus service where you can actually just do top-ups every third or fourth bus stop, and then 4 minutes at the terminus does a complete battery charge. Okay, so that changes the system completely. Another game changer, which I poo-pooed a while ago until I actually went to go and meet the people, is electric roads. Okay, so this is work that's going on in Sweden with Volvo, where they're looking at electrifying the roads. And the kind of classic way of doing it is using inductive charging. What they're doing is they're actually looking at conductive charging, where you actually got a pickup on the line there. I thought this was crazy until I saw this working with a foot of snow over the road. So when you've got a foot of snow, which is, we all know that water is conductive and all the rest of it, and it still works quite happily, it's really interesting. This track here is an older track now where you've got four tracks where you pick up along. They're now busy working on a single track where they alternate AC and DC, alternate positive and negative along the way. And what they do, it's about 2 meters a section, and they swap them around so that basically it's only live when you've got a vehicle going over. If you think how fast vehicles are traveling, you can see how difficult the control problem that's going to be. But it's really exciting to see what's happening. And they got plans to put in a 90-kilometer stretch just outside Oslo for HGVs to actually run on. So this is for vehicles, this is for heavy goods vehicles. Okay, so there's substantial powers going through here. And to me, this is, again, it's the early signs of a game changer of what can happen in heavy goods transport. Okay. The thing that worried me was to say, well, what's the cost going to be? Okay, and they were looking at something between 50 and 100 euros per meter. And if you look at it, you're normally paying about 1,000 euros per meter for a road. It's actually doesn't make a huge difference to the cost of a road when you build it. Okay, so that to me is another little game changer, just an early heads up. But you're going to need 5 years before you see anything exciting happening in that space. So what's the future of mobility going to look like? Okay, it's going to be electric. I don't think there's anything that we can avoid with that. I think it's going to be a lot smarter in all sorts of ways. I think we're going to move away from having vehicles as a commodity and go to mobility as a service. That seems to be a trend in a lot of the cities. Most of you have come across Uber and Lyft and the like, and we think that's going to transform in the way things are going to go through. And the last one is going to be sustainable in that both the quality of lives of people are going to improve, but also our draw on the planet is going to be slightly more gentle. So what are the implications for New Zealand? How do you think they can respond? First hard one is to recognize the inevitability of this. Is that no matter what you do here, internal combustion engines aren't going to be around in 10, 15 years' time. Okay, so that's going to be a real game changer. So what can you do? You can start to plan for what are the infrastructure changes going to happen. That's both the transport infrastructure and also the grid infrastructure, especially within cities. If you've got a whole lot of 400 kilowatt chargers all over the place, that's going to cause merry havoc with your system unless you're very careful about what you're going to do about it. Think about what the co-benefits are going to be. So one of the things we've recognized in Oxford is actually when we're starting to create a zero emission zone, is actually air quality is dramatically improving. There are a whole lot of other co-benefits that we can have, and the question is you've got to recognize what they are for your particular area and how do you capitalize on that, and potentially how do you create value out of those co-benefits. So one of the things we're looking at is actually increasing the rates for those shops that are in a low emission zone because they have a higher footfall of customers. And then how do we incentivize investment? You've already had your minister under the grill on how to do that, and that's something that I think we need to think about. But the most important part is if you haven't started now, you need to start thinking about it now because this is happening. Thank you, ladies and gentlemen.